In this video, we're going to be talking about graphing systems of linear inequalities. So in the previous video, we learned how to graph one inequality. In this video, we're going to be graphing two inequalities, and the solution is going to be the areas where they are overlapped. So it has to be the areas that are true for both inequalities. Looking at this first example here, I can see that the y is isolated on one side. So if I took that whole inequality and I flipped it around, just changing the side that the y is on, 2x, but making sure that the inequality still faces the same direction as before, meaning the open side of this inequality is facing the y, the open side of the inequality is still facing the y. This would be equivalent. And when I write it this way, it's more aesthetically pleasing and looks like the form y equals mx plus b. So I can go ahead and graph that line using the slope and the intercept. So looking at this, the coefficient to the x is 2, meaning the slope is 2, and there is no y-intercept value. That means that I've added nothing, it's plus 0, and the y-intercept is at 0, 0. So starting at the origin, I can use my slope of 2, which is rise over run, and we write that as a fraction. 2 is the same thing as 2 over 1. So from here I would move positive 2 and then positive 1. And I could keep doing that to make more points on my graph. Or two negatives make a positive, so I could go negative 2, negative 1. Negative 2, negative 1. And get even more points on my graph. Now, looking at this inequality, I have to decide. Is it solid or dashed? In this case, solid. So I go ahead and I make my line solid. Alright, for this inequality, I'm going to shade the area green. So I'm going to test a point to be able to know where to shade. I cannot use 0, 0 because that's on my line. I have to pick any other point. I'm going to go ahead and pick 2, 1, because that's clearly not on the line. So 2, 1. Plug it into my original inequality. 2 times my x. Is that less than or equal to my y? 2 times 2 is 4. Is 4 less than or equal to 1? No, that's false. So the point 2, 1 was here. And that is not where I'm going to shade because that was false. It's not a solution. So I have to shade the other side of my line. So all of this will be the solution to just the first inequality. So this is not my actual final answer yet. Alright, so now I have to graph. So that was inequality 1, I'm going to call it. Let's look at the second one here. And actually, let me use a different color. Alright, so this inequality, there's one of two ways that we could graph it, or one of three ways really. We could use a table, we could try to get it into slope-intercept form, since it's not currently, it's in standard form, or look for the x and y intercepts. I look at the coefficients of 1 and 4. They would both divide evenly into this 4, so I'm going to go ahead and do that with the x and y intercepts. Meaning, let 0 equal, or let x equal 0, so 0 plus 4y, that's gone. I could divide by 4 to get y alone, and y would equal 1. And then I can let y equal 0, so x plus 4 replacing y with 0, 0 times anything is 0. So that means that x would equal 4. And now I have those 2 points that I can graph. Then I go I go up 1 on the y-axis for my y-intercept, and positive 4 on the x-axis for my x-intercept. 1, 2, 3, 4. have to go back and decide this is also solid. So it's a solid line. We're going to pretend that that's straighter than it is. And then I still have to test to know where to shade. This does not go through 0, 0, so I can use that as my test point. So I'm going to fill in, again, into the second equation, 0 for x and 0 for y. So I get 0 plus 0, which equals 0. And I have here is 0 greater than or equal to 4. And that is also false. So the point 0, 0 was here. This side was false, so I have to shade the other side. So everything that I've shaded is not the answer. It's not everything. However, it is the overlap in the two. So I see I have the green color and the purple color. That is actually the solution area. So only this section here is what would make both inequalities true. Right? So to be a solution, it has to make both the first and the second inequality true. So all of these values here are the solution area. This purple area made the purple line true, and this green area made the green, but the answer is this black area. Only this shaded black area is what makes the system or both inequalities true. Go ahead and try the second problem. Alright, in this example, we're asked to graph the solutions to this system of linear inequalities. This first equation is in the form y equals mx plus b already. Right, so we have our y all alone on one side of the inequality. I can identify the slope as 1. This is 1x, and the y-intercept is 3, which would give me the coordinate 0, 3. I'm going to go ahead and use these to graph. Remember, step 1 is graphing the lines. I start on the y-intercept at 1, 2, 3 on the y-axis. I have a slope of positive 1. Remember, 1 can be written as 1 over 1. So a rise of 1, a run of 1. A rise of 1, a run of 1. I could also go in the negative direction, right? Down 1, back 1. Because two negatives make a positive. And this is going to form my line. I have to be cautious though. I notice here this is less than. That means it's a dashed line. So I'm going to go ahead and just dash this line. It's not a solid line. It means we are not including the line as part of our solution set. So anything on this line is not part of the solution. Alright, so now I need to think about where to shade this line. So I'm going to test a point that is not on the line. In this case, 0, 0 is not on the line. This is equation 1 here, or inequality 1. Alright, so I filled it into the original inequality, replacing y with 0, replacing x with 0. Is 0 less than 3? That is true. If it's true, that means that's the side I shade. So 0, 0 is here at the origin. It was true. I shade this side of my line. Right, again, this is not the final answer. I need to graph this other line. Let me use a different color. Looking at this inequality, I notice that if I subtract 2x from both sides, I'll have y greater than negative 2x minus 2. So all I have to do is subtract that 2x over, and now it's in slope-intercept form again, that y equals mx plus b. That means my slope is the coefficient to the x, or negative 2. Same thing as negative 2 over 1. And my y-intercept is negative 2 also, giving me the coordinate 0, negative 2. So I start by plotting my y-intercept at negative 2, and then I move from there using my slope. So a rise of negative 2, so down 2, and then positive 1. Down 2, positive 1. And then from there, I could also find other points if I move the negative in the denominator, right? I only have one negative, so I can only use it once. But I can go positive 2, and then in the negative direction. Positive 2 in the negative direction. And before I draw my line, I look at my inequality. This is a greater than. Since it's a greater than, that means it's going to be a dashed line. There is no equal to bar. So the same thing here, I'm going to dash my line, showing that the line is not part of my solution set. And then lastly, I need to test. So again, 0, 0 is not on the line. I can use that as my test point. I fill in the original equation. 2 times 0 plus 0, is that greater than negative 2? 0 times anything is 0. 0 plus 0 is 0. Is 0 greater than negative 2? That is true. Right? 0 is further right on the number line than negative 2. So the point 0, 0 was here. So this is the side of the purple line that I shade. Everything over here. And again, that whole picture is not my solution set. The solution set is only the overlap of the two. So where I see the purple and the green, this is the solution area. And you need to make this clear on your tests and things like that, so that it's clear that we know that you understand the solution area is only the overlapped area between the two inequalities. So that is the solution area. Alright, and there you go. That's solving systems. You graph one inequality, graph the other inequality, and then the overlapped area is the solution set.